My name is Dani Medina, and I'm a research fellow with the center, and I'll be your host for this seminar today. So today we have a really exciting presentation. We're going to be listening about climate change, climate variability, and applications of early warning systems in the Pacific. And today we're being joined by Professor Scott Power, who is the director of the Center for Applied Climate Sciences at the University of Southern Queensland. He is also a climate science advisor for DFAT, funded Australia Pacific Climate Partnership Project, and an associate investigator in the ARC Center of Excellence for Climate Extremes. He's an expert in climate change and climate variability, and he's had more than 20 years of experience working in leading research roles for the Bureau of Meteorology, and he's also the climate science advisor for the Australian government for the Climate Change Authority of 2018 and 2021. So most of his presentation is going to focus on the implications of the frequency of record-breaking high temperatures projected over the coming decades in the Pacific, which are among the highest in the world. And then Scott will also discuss a project that he co-managed aimed at increasing the community benefits of early warning systems in the Solomon Islands. So quite an interesting presentation. And please join me in welcoming Professor Scott today, and the floor is yours.
Thank you very much, Danny. Yes, I just used this. Yep. Yeah, thanks again, and thanks also to Mel, Inez, Brittany, and the whole team for organising the event. And I know they've gone to a lot of trouble, so thank you very much. Good morning, good afternoon, everybody. Yeah, as Mel was saying, that I'd like to talk about climate change, climate variability, and early warning, early action systems in the Pacific. And really, I'd like to talk about three things. First, the past, then the future, and how Pacific Island countries are managing risks associated with climate change. And when we get to the part, when we're looking at the past, I just want to emphasize the importance of climate variability in the Pacific, and not just from year to year, but also from decade to decade and from generation to generation. And then we'll look at how some of the things that have changed in the Pacific over the last 50 years or so, and then briefly talk about the causes of some of those changes. And then we'll turn to the future and we'll look at some of the projections for the region. And then finally, we'll look at a project that I was fortunate to be involved with in the Solomon Islands aimed at increasing community benefits from early warning, early action systems in the Solomon Islands. So let's begin by looking at the past. And what this shows is a time series of annual rainfall in Tuvalu from 1950 through to near present. And it's in millimetres. So each bar represents the total amount of rainfall received in a given year. And you can see there's a huge, we'll get to the colours in a moment. You can see there's a huge amount of variability. So for example, in 1950, there was around about 250 millimetres. Whereas if you look at 1950, 51, 52, 53, it was approaching, it was over 4,000 millimetres. That's a huge amount of variability in rainfall in this part of the world, in Nauru. Sorry, it's Nauru, I should have said. And you can also see the colours, and the aqua colours indicate El Nino years, and the darker bluey type colour indicates La Nina years. And you can see, and I'll explain what they are in a moment, but I'm sure most people know it already. But you can see that in this part of the world, during El Nino, the rainfall tends to be higher, whereas during La Nina years, the rainfall in this part of the world tends to be lower. So that's the opposite to what happens in Australia, for example. It's also the opposite to what tends to happen in Samoa and Solomon Islands, for example. And one of the main reasons, as you might have guessed from the previous slide, for this high degree of variability is because much of the Pacific is influenced by a highly irregular oscillation called the El Nino Southern Oscillation, which consists of three phases, two of which we just looked at, La Nina and El Nino, and then a neutral phase when not much is happening. But it's important to, there are numerous changes associated with ENSO. So on the left, we can see some of the changes that tend to occur during La Nina years. By the way, we've just been through 3 La Nina years, and the Bureau just put out a an alert for a watch for El Nino, which indicates that there's a 50% chance of El Nino occurring this year. And the long-term average rate of El Ninos is around about 20–25%. So the probability of an El Nino this year is double what it normally is. So we have to keep our eye out for that. But as I said, the last 3 years have been La Nina years, one after the other, which is very unusual, but not unprecedented. And what tends to happen during La Nina is that in the trade winds tend to get stronger, tend to get more rainfall over Australia. The waters to the north of Australia tend to be warmer than normal. They're already very warm, but they even get warmer still, whereas the waters over in the east tend to get cooler. And that's partially associated with increased upwelling, which brings colder water to the surface. And those stronger trade winds are a part of this whole circulation, this vertical circulation called the Walker circulation. And that gets stronger as well during La Nina years. And you tend to get greater rainfall north of Australia associated with really strong atmospheric convection. And then during El Nino years, which is kind of sort of the opposite of La Nina, not quite, but you tend to get weaker trade winds. Sometimes the Walker circulation can get disrupted. You tend to get the very warm waters north of Australia tend to get a little bit less warm. The waters over in the central and the eastern Pacific, indicated by the red here, tend to warm up. And the upwelling tends to diminish, and you also get associated oceanic changes. So this naturally occurring oscillation affects climate from year to year, and it influences not just countries in the Pacific, but also countries around the Pacific and even beyond to India and South Africa, for example, and South America. But it's important to realise that the climate in the Pacific doesn't just vary from year to year. It also varies from decade to decade and generation to generation and even longer. And these are, from a recent review, lots of different time series of various things. So for example, the top one, and I should point out that all of the time series have been filtered so that you only see variability from decade to decade or longer. And so there's no year-to-year variability. So you can see that every single one of them displays substantial decadal and longer-term variability, and some of them exhibit changes as well. So the top one, Nino 3.4, that's the term that climate scientists use for a box in the middle of the Pacific. So it's a measure of the temperature variability in the middle of the equatorial Pacific. So you can see there's lots of variability, but not much of a trend. Whereas if you go to the West Pacific, so this one here, you can see, so it's this time series. You can see that again, there's lots of variability, even generational to generation variability, but there's also been a trend to higher temperatures. And then that tends to echo the globally averaged temperature record down the bottom. So no matter where you look, you get variability in the Pacific pretty much from year to year, decade to decade, generation to generation. And in some parts, you see these very substantial trends, long-term trends. And a lot of the decade we saw before, that a lot of the year-to-year variability in rainfall, temperature is driven by the El Nino southern oscillation, El Nino La Nina cycle. Whereas from decade to decade and generation to generation, a lot of that variability is driven by something called the interdecadal Pacific oscillation, or IPO. And the pattern, there are two patterns here. They're both IPO, interdecadal Pacific oscillation patterns, but the one on the left is derived from observational records. So it indicates that you get this flip-flop. This is a particular phase of that pattern when it's very warm in the Central Eastern Pacific. And these patterns are very similar to the sorts of patterns you get for El Nino. But this is variability on much longer timescales than year to year. And when you get warmer water in the Central Eastern Pacific here, you tend to get cooler waters to the northeast of Australia in the Southwest Pacific. And then this is exactly the same thing, except this is derived from climate models, so mathematical models of the climate system. And you get these sort of patterns in climate models, even if you don't force them with changes in greenhouse gases or things like that. They occur naturally in the climate model. And so that's a further indication that this is a naturally occurring phenomenon. The interdecadal Pacific oscillation, like ENSO, El Nino Southern Oscillation, they're both naturally occurring phenomena. And it's because they occur pretty much because the equatorial Pacific is an unstable situation. It doesn't like to sit still. But also when we looked before at these time series, we saw that in the West Pacific, for example, and other places, there are significant trends, long-term trends. Things are getting warmer. And in fact, a paper here by Simon McGree at the Bureau of Meteorology, he worked with his colleagues in the Pacific and elsewhere and produced a really nice map showing the sign and the magnitude of trends in surface air temperature from multiple stations across the Pacific. And you can see that they're all red, and red indicates that all of the trends in all of the data here are warming trends. So all of these locations warmed up. And in fact, if I had have shown it for Australia, you would have seen the same thing, that since 1910, when our national record is available, all of Australia, every single location has warmed up. So it's a very clear picture of warming across the country. Some places the warming's a bit stronger than others. But now let's look at, in more detail, what's going on in a few of these different locations. So what this shows, before we looked at a time series that looked like this for rainfall, but this is a time series of average temperature in Funafuti, and from 1950 through to near present. So this is temperature, average temperature for each year. So you can see that it began in the early part of the record, it seemed to wobble around 27.5 degrees-ish Celsius, whereas now we're up around 28.5 or 29 even, a bit hard to read off here, but 29 degrees Celsius. And you can see that, again, there's lots of variability in the temperature, but there's this in this particular location, the trend is extremely prominent. And, you know, some people might say, oh, that's the signal to noise. So this warming is from anthropogenic forcing, an increase in greenhouse gases, primarily carbon dioxide. But one way of saying that is that the signal from anthropogenic forcing is very strong compared with the noise, the natural variability. But you can even, you can highlight just how big it is by looking at the warmest temperature, the highest temperature that we had prior to 1970, indicated by that black arrow. If you draw a red dashed line across from that highest value ever recorded in the historical record for that pre-1970 period, you can see that in recent times, every single year has been warmer than what was experienced back then. It's pretty remarkable. So in other words, people now are experiencing things that are unprecedented in the historical times prior to 1970. And when that happens, one term for that is climatic expulsion. So that anthropogenic forcing, greenhouse gas increases, have pushed the climate system, as reflected in the temperature record in this part of the world, beyond the sort of envelope of variability that it used to experience prior to 1970. So we shouldn't be surprised to find things that are challenging people and ecosystems, given that that's a fairly major change in terms of the variability that they've experienced in the past, or the recent past, prior to 1970. And by the way, the data, Simon and his team have updated the data for a number of different locations across the Pacific, and I pulled out the ones where they also seem to exhibit a form of this climatic expulsion, where the trend is so large that temperature variability now, or temperature, seems to be above what it used to be the whole time prior to about 1970, or the earlier part of the record. So for example, start over here. So let's see, this is in Honiara in Solomon Islands. There are, in each plot, in each panel, there are 3 records. One's the temperature for the wet season. That's the warmest one, typically. And then there's the annual average, all months. And then there's the May to October value. So it tends to be warmer during the wet season, and in each location, except perhaps one. And you can see, if you look at what's been happening in recent times, you can see that it tends to be, in pretty much every case, tends to be above the sort of envelope of variability that used to be experienced prior to 1970. So this, in the previous slide, we saw that it was occurring here in Funafuti, but you can see that there are other places in the Pacific where the same thing is true. This doesn't occur everywhere, but it does occur in some of these locations. And as I mentioned, that, you know, we therefore shouldn't be surprised that we're seeing things that are challenging ecosystems and people. So that's what's happened in the past. So we've seen a huge amount of variability from the El Nino Southern Isolation. We've seen a huge amount of variability from decade to decade, generation to generation, all natural. all natural variability, but very, very important for the region. Not only affects temperature, but it affects sea level, winds, and rainfall, especially, or in particular. So that's the past. Oh, and we also saw that there's decadal variability and longer term associated, much of that, not all of it, but much of it is associated with this other natural thing called the interdecadal Pacific Oscillation. And, but we also saw some underlying trends. And in terms of temperature, those underlying trends are dominated by, that they're driven by increases in greenhouse gases through human activity, primarily through burning fossil fuels, but also deforestation and other things. So in order to anticipate what might happen in the future, what climate scientists do is to use climate models, which I referred to briefly before. And a climate model is a mathematical model of the physics of the climate system. So in the global models, we run them on supercomputers, and we have mathematical equations for the ocean. We have mathematical equations for the atmosphere. We have equations that link them together. So there are interactions between the atmosphere and the ocean. We have equations for sea ice and a number of other things. And so what we can do is we can run these models just with natural processes. And lo and behold, we get, as I alluded to before, they all exhibit their own ENSOs. They all exhibit their own interdecadal Pacific oscillations. But what we can do in the future, to anticipate the future, is we can also force them with what we expect might happen to, for example, carbon dioxide over the future. But the trouble is, we don't know exactly what is going to happen to carbon dioxide, which is an important greenhouse gas, by the way, carbon dioxide. We don't know what's going to happen exactly to carbon dioxide levels in the future. So if emissions of greenhouse gases, net emissions of greenhouse gases aren't curbed substantially, then we would have very high much higher concentrations of carbon dioxide, for example. But if the Paris Agreement is swimmingly successful, so the Paris Agreement, where everyone's, pretty much every country in the world is agreeing to reduce their emissions so that we ultimately hope to keep globally average temperature change below 2 degrees Celsius, and hopefully get as close as we can to 1.5 degrees Celsius of warming relative to what it was in the latter half of the 19th century. So if that comes off, then we would have less change in carbon dioxide concentrations. So given that we don't know what's going to happen, we all hope that the Paris Agreement is going to be extremely successful, but we don't know. Time will tell. So what climate scientists do is say, okay, fine, we don't know what is going to happen. So what we'll do is we'll consider both of those scenarios and see what happens under those scenarios. And we might look at the difference between those scenarios, and that will tell us what some of the benefits are of reducing emissions. And so what we know is when you do that and you get lots of different climate models from around the world, this is a study by CSIRO and SPREP, and these are projections for the Solomon Islands region. And this shows the temperature average over that Solomon Islands region, both from 1860 through to 2080. And you can see lots of variability in the early part of the record where it's back here. Then as time goes on, it tends to warm up, and it warms up a lot in one of those scenarios where greenhouse gases tend to increase a lot, but it's curbed to an extent if greenhouse gas emissions are reduced substantially. But you can see that both of these scenarios, the world, or this part of the world near the Solomon Islands, is warmer than it used to be. So even this scenario isn't going to get us back to where we were prior to the Industrial Revolution. So, and you can also see the little black, there's an envelope of possibilities. So because of two reasons. First of all, let's look at the black part. Each model has its own variability. And this is just an example. Oh, that's the observed, that black one. And the envelope is what the models tell us should have happened. You can see that the models tend to capture what the real world did, but the models have their own ENSOs and they have their own phasing. So you get an envelope of possibilities. And the same is true for the future. But the other thing that happens with the models is that some models are more sensitive to the greenhouse gas increases than other models. So you get a spread of possibilities. So under this scenario here, covered up a little bit, but you get a spread of possibilities, but they all warm up more than what the temperature was back in the early part of the 20th century, for example. Now, an important point to note when things warm up. So say if you've got a bell-shaped curve, say it's the temperature variability in a particular location. So this is a highly idealized example, just a schematic to illustrate the point that I'm going to make. And let's suppose that this is a temperature anomaly, so deviations away from a long-term average. And so like pretty much anything you care to look at, you get a distribution of possibilities. So this is what the bell-shaped curve, normal distribution, the relative frequency curve looked like for temperature anomalies in a particular part of the world in historical periods, let's say the 20th century. So most of the time you're in this particular make-believe location, temperatures tended to be between 1 and -1, temperature anomalies, between 1 and -1 degrees Celsius. But every now and then, on rare occasions, the temperature would exceed 2 degrees Celsius. That's in the old days, in the 20th century, let's say. And then the other curve is exactly the same thing, but for some future time when the world, including this location, had warmed up. So the whole thing, the simplest model is that the whole thing shifts to the right, to a higher temperature. So the average has gone up. Doesn't seem to have gone up by much, but there's some very, very interesting things happening at the tail of the distribution, the tail of the distributions. So first of all, you can see that 2, it used to be a rare event. For those of you who have done statistics will know that the likelihood of exceeding any given value is represented by the area under the graph. So to get above, in the old days, to get above 2 degrees Celsius, the probability was represented by that tiny little area. Whereas in the future climate, it's still smallish, but it's much, much, much larger than it used to be. So the chance of you experiencing an extreme high temperature in this part of the world is much greater than it used to be because of this warming of the whole and the shifting of the whole distribution. But the other interesting thing to note is that you would expect, let's say if you look at 2.5 degrees Celsius, it was virtually impossible. It virtually never happened. Extremely, extremely unlikely. You can almost rule it out. Whereas now we've shifted 2.5, it's still a small area, but it's certainly not impossible. It's going to happen. And so people talk about, oh, the world's going to warm up by 1 degree, 2 degrees, and some people think big deal. Whereas you need to worry about this effect. Whereas in Australia, we're not talking about 1 or 2 degrees. Might be talking about 40 degrees or 50 degrees. So in the old days, you might not have ever seen some of these extreme temperatures, or they might have been extremely rare. But because of climate change, we're now seeing them much, much more often than we used to. And the same is true in the Pacific. It's particularly true in the Pacific. And that's what I wanted to, this is an introduction to some work that we did. So what we did was we took multiple climate models from around the world and we looked at how often are we going to experience record-breaking temperatures, so record-breaking high temperatures, so the temperatures that we've never witnessed before in the historical record. And this is what this shows is the percentage of the world that sets a new record in a given year from, good question, I think it's from the year 2000-ish through to 2100. That's dropped off the bottom there. So this is the 21st century, let's say. And there are there's a lot of information on this plot. So this is basically saying that we go back to, I'm going to go off the screen here, aren't I? We go back to the beginning, you can see that for these two scenarios, that around about 30 to 40% of the world would break a record. So let's start by looking at this one here. So this is all information taken from climate models, but they are under different scenarios. So the first one, this one down here, the grey, that is from models that haven't had any external forcing, any forcing from greenhouse gases. It's all completely natural, so that all the variability is generated naturally within the model. So it has ENSOs and IPOs and lots of other different things. And it indicates that at this in beginning of the 21st century, that around about 10% of the world would experience a record in any given year. I think so you're seeing something you haven't seen before. And then as time goes on, it gets harder and harder to break the record because the records increase. So by the end, you're sort of here, if there wasn't any human influence on the climate system. So it's not very likely. So this is the likelihood that you'll break a monthly record in any given year. And so it turns out that by the end of the 21st century, if humans weren't changing the climate of the Earth, it would be about 10% of the world in any given year, which seems like quite a lot. But then you compare that to what happens with the fact that we humans have increased greenhouse gases. So we've increased the magnitude of the greenhouse effect, and we've increased the temperature of the planet. So instead of it being 10%, it's now 30 to 40%. Well, it was 30 to 40%. But then what happens is, depends on what the scenario is for carbon dioxide, for example. If carbon dioxide net emissions go up substantially, then the frequency with which we set new records gets higher and higher and higher. Again, this is spread is because different models give you slightly different answers and the models have their own variability. But if you average across all the models, that's what the red is, you get a rough estimate of what it will be in the future. So it's sort of, what's that, 65%-ish, compared to a natural world, which is about 10%, less than 10%. So we've markedly increased the likelihood that we're going to break records. We've markedly increased the likelihood that we're going to be seeing things that we haven't seen before, if the Paris Agreement was grossly unsuccessful. But if the Paris Agreement this is approaching a successful Paris Agreement, this blue one, you can see that things are much better, but we're still seeing unprecedented things, breaking records about twice as fast as we really should be. But let's now look at what we're currently living through. So where is it? I think it might be 220, 230-ish. That's about 230. Yeah, that's about 230, 240. So that's 2030, 2040. So we're sort of in here somewhere. Okay. Yeah, so I think that's 2030 and 2040. So I think that's 2020. So we're sort of in here somewhere. And so you can see that, in the papers all the time, you hear about, unprecedented record breaking, and people are sort of getting a bit sick of it. But you have to remember that we are breaking records, seeing things much, much more often than we really should be because of climate change, at least in terms of monthly temperature records. And what else can I say? The other thing is that, clearly we need to reduce net global greenhouse gas emissions. We don't want to get up here. We're pretty much, most years we're going to be seeing something. Most years, or most places will be seeing things they haven't seen before. Virtually, it's just a very unpleasant place to be. And you can see that the trouble is that, yes, we need to reduce emissions, but you don't really get the maximum benefit until you start getting out here, towards the middle of the century. We have to put up with elevated rates of unprecedented things for decades to come, no matter what we do, even if Paris is successful. So the world has definitely changed. So that's globally averaged. One way of thinking about this is that there's a 10% in the global average likelihood that you're going to break a record, see a monthly temperature higher than has been experienced during the historical period is 10%. If humans hadn't warmed the planet. But in fact, it's around about 30 to 40% because we actually have. And then as time goes on, it'll either drop to something like 10, 15, 20%, or it might increase further to around about 60%. That's global average. But it turns out that the rate at which we're going to set new records, the rate at which we'll see temperatures we haven't seen before, monthly temperatures, varies from place to place. And so this is a map showing the rate at which we're going to be, the rate at which we're going to be setting records. And you can see that the yellowy ones means that it tends to be lower than the global average rate. whereas the pinkies and purples tend to be places where you're going to break records at a faster than global average rate. So you can see that most of the pinks and purples tend to be at lower latitudes. And the little dots indicate the capital cities of 3 different sorts of countries. The yellow is sort of the wealthy countries. The green are the small island developing states, is what the United Nations calls them anyway. And then the blue are least developed countries. And you can see that the vast majority of the small island developing states are at lower latitudes, and the vast majority of the least developed countries are at lower latitudes, where the rate at which we're going to experience unprecedented things is higher. So it's just another example where the countries who are generating the least amount of greenhouse gas are actually experiencing some of the greater, as a rough rule of thumb, some of the greater effects. All right, so what conclusions can we draw from this study? So first of all, unprecedented record-setting monthly high temperatures can be experienced more often will be experienced more often in Pacific Island countries than in developed countries. And we saw that reducing emissions, net global greenhouse gas emissions, has a marked impact on the rate at which we'll be setting records. However, we saw that it takes about 20 years or more to see the major benefits of reducing those emissions. So we have to be very patient. And some of the implications are that people managing systems affected by extreme high monthly temperatures will need to manage risks associated with the frequent occurrence of unprecedented high temperatures for at least the next few decades, and that natural systems will need to withstand the frequent occurrence of unprecedented temperatures for at least the next few years. So in this particular context, the past is not, we've seen this climatic expulsion, how temperatures are higher than they tended to be in the 1970s. So you have to be very careful about using the past in some context as a guide to the future. And so you can imagine that this is all, if management systems have been built on what's been experienced, then it might not surprise us if some of those systems may become less effective or they may become ineffective. But it will depend on context. Well, so clearly it's climate change is a major problem for Pacific Island countries. So how are they managing the risks associated with climate change? And the 4 things that I can think of are, first of all, they're reducing their own net greenhouse gas emissions, even though it's recognised that that's a smaller fraction of the global average. They're not the main producers, but nevertheless, they are reducing their own net greenhouse gas emissions. They're also encouraging others to reduce their emissions, including Australia, behind the scenes and through the Paris negotiation, UNFCCC negotiations. They're also starting to adapt to climate change in many ways, and heard about some work that's being done in Fiji this morning. And then they're also seeking support for 1 and 3 because they didn't generate the problem. So through UNFCCC processes and country donorship. So they're seeking support, for example, through the Green Climate Fund to help them reduce their own emissions, but also to adapt to climate change. And there are many other sources of funding, but the need is huge and largely unmet. So for those of you who may not work in this particular area, what is climate change adaptation? Well, in human systems, adaptation is defined as the process of adjustment to actual or expected climate change and its effects in order to moderate harm or take advantage of any beneficial opportunities. So you're responding to things you've seen or things you anticipate and trying to make sure that if it's going to cause harm, that those changes, you want to moderate it or you want to take advantage of any opportunities that might emerge from that change. In natural systems, adaptation is the process of adjustment to actual climate and its effects. And as noted by the IPCC, human intervention may facilitate this. So a simple example of adaptation would be to add a veranda to the west side of your house to reduce afternoon heating. So you're not reducing emissions, you've got a problem and you're trying to address it directly, you're adapting to the change. And one form, there are many, many different forms of adaptation. So there's the form that Mel was telling me about this morning involving mangrove plantation, mangrove reforestation, if you like. But another form which probably gets less attention is the case of early warning, early action systems. And you could regard that, strengthening an early warning, early action system as a form of adaptation if, for example, the hazard that's being forecasted was being exacerbated by climate change. So we know, for example, that climate change is projected to potentially increase the intensity of tropical cyclones, which is a major problem for many Pacific Island countries, although they may become fewer in number. So if you have a system which helps people to anticipate cyclones and take action to reduce the harm caused by those cyclones, then that could be regarded as a form of climate change adaptation. And so what do people mean when they refer to an early warning, early action system? Well, there are multiple, in the context of communities, there are multiple ingredients for early warning. I should drop that. How do I get that? Sorry, whoever that was. So first of all, which sometimes gets forgotten, is that, well, the community needs to be aware of the hazards that they face and what the associated risks are, what it might do to them. And also, as part of an early warning, early action system, early warnings need to be produced and tailored for use by that community. The early warnings, there's no point producing a forecast if it's not disseminated. Early warnings need to be disseminated by, for example, radio. And then over the top, early warnings need to be reliably received. So there's no point if you disseminate it and the people don't have it via radio and they don't have a radio, then you're not. It's not a good early warning, early action system. But then even if they're received, they need to be understood, and so that's an important ingredient. And then there needs to be plans in place so that when they receive that warning, they know what they're going to do. They have a plan in place to take action in the event that they receive the warning, and then they take the appropriate action. So you can see that there's quite a few different ingredients to an early warning, early action system, or a robust one. And we were really interested. I was working with World Vision. I was working in the Bureau of Meteorology, but I was collaborating with people in World Vision, and we really wanted to get experts together from around Australia and the Southwest Pacific and ask them about how do we generate more benefit to communities from early warning systems, more lasting benefits from early warning systems. So we got about 40 different people from around the region and asked them those questions, had lots of discussions and presentations. And that included World Vision, National Met Services from Vanuatu and from Solomon Islands, Bureau of Meteorology, World Meteorological Organisation, DFAT, SPREP, Red Cross, CBM, which specialises in inclusion, Oxfam and International Women's Development Agency and others. And what we found was that while many agencies are now supporting the development of early warning, early action systems in the Pacific, so it was all about the Pacific and East and Timor-Leste, the space appears crowded. So you think, oh, gee, there's so much going on, it's fantastic. But as I mentioned before, the reality is that the demand for these early warning, early action systems for communities is huge across the Pacific. And so most projects are only dealing with a tiny subset of the total number of communities or a subset of the provinces, perhaps I'm not sure about the countries anymore. And typically the projects only have short lifetimes. So there's some fantastic work being done, but much more work needs to be done. And we also noted that it would be great if there was greater coordination of what's going on at the various levels. And we also noted, so this is a sort of preamble to the project that we're doing. So this was a workshop we had where we wanted to get all the expertise available before we designed the details of our project and try and make sure that it was consistent with, a broader understanding of this sort of large community of experts. And we also saw that there's enormous potential to simplify the early warnings in the Pacific and increase the understanding and awareness of the early warnings through enhanced collaboration between the communities with many others, including NGOs and the National Meteorological Services, National Disaster Management Offices, and many others. We also heard that it's really important when strengthening early warning, early action systems that the detailed context of the communities you're collaborating with is taken into account. We also heard about the importance of national disaster management offices in early warning, early action systems in the Pacific. And one important point was that we heard there was great opportunity for some of the technical agencies to work with the NGOs, because they have very strong, and church groups too, I should say, they have strong links with communities, long-lasting trusted relationships. Whereas the meteorological services they don't have the resources to get out there all the time, so they can collaborate with communities via collaborations with NGOs. And we heard that NGOs can facilitate stronger relationships between, I'm basically repeating myself, between communities and the national and provincial agencies issuing early warnings, and thereby help the agencies tailor and deliver the early warnings in a manner that better meets community needs. So armed with that and lots of other information, we then designed our project, which was aimed at increasing community benefits in a particular island, Makira, in the Solomon Islands. And this was a project funded by the Department of Foreign Affairs and Trade, and it was part of something called the Australian Humanitarian Partnership. There's an element of that called Disaster Ready. And I was very fortunate to have many partners in the Solomon Islands and in Australia. And some of the partners in the Solomon Islands included David Heber, who's the Director of the National Meteorological Service, Lloyd Tahini, Kayleen, Beniga, Alex from the Solomon Islands Met Service, and also Bettina Devesi, Charles Oloka, and Alfred Peary from World Vision Solomon Islands, and Cedric Hobrecht back here in Australia, working at World Vision, and of course, some of the community representatives, amongst others. There's many other partners in the project. And as I mentioned, it was funded through something called the AHP, Australian Humanitarian Partnership, which is still ongoing. It's been regenerated, it's got a new form. And we worked in an island called Makira. Initially, we worked with 4 communities. You can see along the coast there. They're all on what the so-called weather coast. So they're subject to a wide range of hazards, including coastal inundation, tsunamis, earthquakes, malaria, tropical cyclones, flood. And then later on in the project, we added 4 additional communities to the project. So in the end, there was a total of 8 communities that we were working with. And here's a map that Cedric from World Vision knocked up in about an hour, just walking around, and shows what the village looked like. The communities tended to have around about 400 people-ish. Some had about 250, some had more than 400. And here is just one particular community, Manita. And there's some of the people, and you can see what the community tended to look like. So there's very little electricity, beautiful place, very, very friendly, lovely people. And they're all on the coast, every single one that we dealt with. Some of them had, I'll leave it there. And then to kick the project off, we had a national workshop to do the same sort of thing, to collect all of the expertise in relation to how do you increase benefits to communities from early warning, early action systems. And we held it in Honiara, and it was convened by the Met Service, by myself and World Vision. And we invited, and people attended from the National Disaster Management Office and several other government departments, electricity and water, utilities, NGOs, Red Cross, people with disabilities office, the Broadcasting Corporation, and importantly, and others, including church reps, and importantly, community representatives. And that was fantastic to have them there. And they had very, very few opportunities to get to Honiara, very few opportunities for them to get up in front of all of these technical agencies and give them a reality check on the situation actually in the communities. It was extremely valuable, and Yeah, really good. And what we found from this meeting, or what I learned from the meeting, was that, yes, the communities were aware of the hazards. And in this project, when we visited, we found that the one that was at the top of their list of concern was tropical cyclones. So that's what we focused on, because we felt that there was a lot of work going on, but it was only touching the surface. So we really wanted to get down to have a significant impact. And so we narrowed down to only 8 communities, and we narrowed down to one hazard, the one that they were most concerned about. And that turned out to be a huge amount of work, just that one alone. And so we found out from the discussions we had from the workshop and subsequent consultations that, yep, communities were aware of the hazards and the associated risks, including tropical cyclones. Yes, the early warnings were being produced, and yes, the early warnings were being disseminated by EG Radio, by the Broadcasting Corporation. They were being produced by the Solomon Islands Met Service, and the communities were definitely aware of the hazards. So it seemed pretty good. But remember that when we had that previous schematic, there were more things that needed to be addressed in order to have a robust early warning, early action system. And so here is what we also learnt, that they were being disseminated, but they weren't being reliably received. And that was because so one of the community reps got up and said, well, we really like the forecast, but it turns out that we don't get them in our community. It was different for some communities, but in this particular community, and they weren't unusual, that they wouldn't get them when the weather was bad, which is exactly when they needed to get them. The other one that we learnt was that early warnings weren't completely understood from the Met Service, and that's because the Met Service, which is scientifically robust, doing a really good job, but they would, like in Australia and many other places, they would say there's a cyclone that's tracking northwest at 20 knots. And those terms just aren't understood for many people in not just those communities, but many other communities. And then we found that each community had a plan, a disaster management plan, but I don't think any of them, or certainly most of them, didn't have explicitly a plan in place for what do they do about warning in the event of a warning. So that wasn't in place. And so what else? That was right, but they were produced, but they weren't tailored for use. So this was, I wouldn't say music to our ears, it wasn't that. It was, there was plenty of scope for us to potentially have an impact working with the community after we better understood the context in which they live and work. And World Vision also did some really interesting, as part of the project, did some really interesting surveys. So this particular one, this is at the start of the project, just to get a better understanding of what the situation was. Ooh, better hurry up. Found that percentage of household survey respondents reported receiving early warnings. So this is near the beginning. So this is 1, 2, 3, 4, 5 different communities. And you can see that, yes, they received it from SIM, so from the Met Service. So that, most of them, the majority of households received them. Some of them didn't, and some of them weren't sure. So there was scope there to improve the situation. And then how did they receive those warnings? It varied a little bit from community to community, but overall, as I alluded to before, the vast majority received them via radio. Some received them by mobile phones, and some were directly told about them by the police because they live near the major town. And so what did we do to strengthen the early warnings? I might come back to that one because that's the most complicated. But so we did things like, to address all of those issues that we saw on one of the previous slides, we wanted them to reliably receive the warnings. So we gave them, and we also wanted them to be able to, move out in at night time and things like that. So we gave them radios. We gave them mobile phones towards the end when the telephone network was upgraded. We gave them torches. The project gave them torches, I should say. We also purchased a high-frequency radio backpack, military grade, although that hasn't been tested, so it's sort of near. That's still yet to be. That allows them, the communities, one community, because it was so expensive, to talk to people in the main city in the event of an emergency or a medical issue. So I'll be keen to go back at some stage so we can sort of see how that's working out. World Vision and Meteorological Service help facilitate training drills for what they might do in the event of getting a warning. We provided them with materials so that they could build notice boards. This is during the construction phase in each community, so they could put up posters and whatever else. We provided funding to support signage. In this case, it was tsunami signs to go in the communities. And we provided weather kits to increase understand or add to the traditional understanding they have of fantastic traditional understanding they have of weather, but to increase that understanding to include some things from Western or from science, or other forms of science, I should say. We gave them some training in the use of the weather kits, and this would go to the schools as well. They included thermometer and things like that, rain gauge. We helped facilitate the production of calendars that agricultural calendars. So this is all based on the community's knowledge of when things occur environmentally and in agriculture in their part of the world. And we produced lots of different posters to increase understanding of cyclones, for example, floods, and how they access the forecast. And then the one I skipped was this one. So remember before I said that the forecast went out things like, oh, there's a cyclone tracking southwesterly direction at 20 knots. So instead of doing that, we developed this prototype, and this was inspired by what was happening in Vanuatu, but through the Met director David in Solomon Islands. This is really his baby. And what they did was produce these maps, gridded maps. So it's A6, B7. And so then the Broadcasting Corporation, instead of saying 20 knots, southwest, they can say the cyclone is now at L6, and tomorrow at 6 o'clock, it's going to be at B4 or whatever. And each community would get those maps. It would go up the notice board. The various people would have it, and then they would then develop a plan based on the warnings. And then another thing we did was, remember before we talked about the importance of El Nino, La Nina, the ENSO cycle. So there was, from a previous project I was involved with called the Pacific Climate Change Science Program, we produced a video which helps to explain the impact of El Nino, La Nina on Pacific Island countries, mostly rainfall and ocean temperatures. But it was really, really good, but it was in English. And so in this project, we put in some pigeon audio, we put in some English subscripts, and we put in some person signing. For people who
This is a funny slide, but
so at the end of the project, I feel confident that the early warning, early action systems have been significantly strengthened, so that was already in place. The warnings have been tailored, as you saw, with that B6, C7. That was already in place, but now they're more reliably received. We probably need to go back and even get them even higher quality radios and see how that high frequency radio backpack's going. The early warnings are now much better understood for all the training in schools and for the communities, and by simplifying the messages. And the plans are now in place for what they do when the warnings are received. And as yet, they haven't had cyclones, but we'll see how it all works. So there are all the ticks. But just to finish, and then just to focus on the last really important part, existing plan of action in place and action taken. So a number of factors need to be in place for this to work well. So for example, the roles and responsibilities of each person needs to be understood. And that's in the plan, that's in their village plans now. And there's been drills to help sort of clarify that. Plans obviously need to be inclusive, so no one's left behind, including the elderly or people with other issues. Evacuation routes need to be understood and clearly marked, and we assisted there, as did other projects. And then we need to practice beforehand. And as I've mentioned a couple of times, we certainly did that, or the community certainly did that. But so far should I wrap up or another 2 minutes? All right, well, anyway, so all of what I've talked about was largely based on Western science, whereas we know that there are already lots of existing early warning, early action systems based on traditional knowledge, extremely important in the Pacific. And in fact, what we found was that if people were close to a big city or big town, they would tend to use the Met Service information, whereas the further they were away, the more important traditional knowledge seemed to be. That's what we saw in our communities that we were working with. But one point from the previous part of the presentation was that, the world's changing, climate is changing, and so some of the traditional indicators may not be working as well as they used to. And in fact, maybe some of them, in some contexts, maybe they won't work much at all. And then the other thing is that a lot of the Western science stuff, that's based, if their understanding of hazards is based on their historical past, we saw before that things are changing there too. They're starting to see things they haven't seen before. So I would say that one of the big challenges we now have is to make sure that the early warning, early action systems that are in place or being developed need to take climate change well and truly into account to make sure they're robust. You can't just base it on historical variability, for example. So that's all I wanted to say. So we've looked at the importance of climate variability in the Pacific, not just from year to year, but from decade to decade and generation to generation, natural variability. But we saw that things are changing in response to anthropogenic or human-forced increases in greenhouse gases. And we saw that that's going to, that has led to things being seen that haven't been seen before, at least in the historical record. And that the future is projected using climate models. There's uncertainty, but in some respects, because we don't know how large the emissions are going to be in the future. But we do know the world's going to get warmer, Pacific's going to get warmer, sea level is going to rise, the oceans are going to become more acidic. We're going to be seeing an increased frequency of record-breaking temperatures, for example. But there are things that can be done, climate change adaptation, reducing emissions, and we just looked at one way in which you can adapt to climate change, and we saw that there's quite a lot of work involved in actually achieving on-the-ground benefits. Thank you very much.
Thank you so much, Scott. That was an excellent presentation. And I must say, I'm a big fan of the Pacific Climate Crab. If you haven't seen those videos, they're pretty great. And all the resources actually produced through the Pacific Australian Climate Partnership. So there's excellent resources there. I use them all the time in my own training. So definitely check them out. They're great. So now we might move on to some Q&A. I'm going to just stop the sharing here. And I'd like to ask first if there's any questions from Zoom. Is anyone?
Yeah, sorry.
Yeah, go ahead.
Sorry, Chris Ballard in Canberra. Yeah, I really appreciated that. Thank you very much. Really super clear and super relevant. I work in Vanuatu on traditional knowledge around disasters and climate change. The one thing I would take issue with is this idea that because the climate's changing, traditional knowledge is becoming less relevant. And I'm hearing that from traditional knowledge holders, which is slightly alarming. Yes, in terms of prediction, but I think most traditional forms of weather prediction were always understood to be broad, to put it one way. But what really matters is actually people's capacity to deal with and to manage hazards like cyclones. And in a sense, that doesn't really change. The intensity of the cyclone might be greater than they've experienced, but the basic structures of local disaster management, if you want to call it that, are still in place and will not be replaced by anything delivered by the state in our lifetimes. So they're incredibly important. That doesn't shift. And I think we need to acknowledge that importance. I think you partly do that in this talk. But whenever we say, climate change means traditional knowledge is no longer relevant, I think we need to qualify it almost immediately and say traditional knowledge is always going to be relevant on the ground, whether it's, indigenous knowledge or urban knowledge or whatever. These local knowledge systems are really important.
Yep.
Thanks.
No, I don't think I said what you said. I didn't say. I said that in some contexts that traditional knowledge may become less effective or ineffective. So it depends very much on the context. So, but I do know that my colleagues who live in the Pacific, some people at SPREP, people at USP, they have noticed that in some contexts that some traditional indicators may not be working as well as they used to. But yeah, no, I take your point that we shouldn't interpret what I said as a sweeping statement. Thanks.
Thank you. Do you have any more questions for Zoom, from Zoom or from the audience here in the room? If not, I might pop in just one from myself. So I was just really interested in that early warning system project and like the diversity of partners you showed in that sort of like slide where you had people from NGOs, people from like the med services and so on. So I was curious if you could tell us a little bit more about that experience of collaborating so like across such a diverse range of stakeholders, and what do you think are some of the lessons learned from that collaboration?
So my role was much less involved than the Meteorological Service and World Vision. So they were and the community, so they were the centerpiece. So the way I sort of saw it in the end was that, and one of the benefits of the project, which the Meteorological Service and World Vision both concluded, was that it really did help them to bring them together. And it also helped to fund, to be blunt, it helped to fund some of the Meteorological Service people to actually go to the communities. So they rarely get that opportunity because it's quite expensive and time consuming. So that was one of the really good things. So yeah, I think that was part of the benefits of the project, was it just got people talking more. And one way I came out thinking about it was that, you know, the community, if you think of the communities as being a small part of a big fabric, like a big rug. And we had all the bits and pieces, you know, we had the Met Service there, National Disaster Management Office, you know, and they had their provincial office, and we had World Vision and the churches and all that. And they're all kind of linked, but what the project did in one, and it's only for 8 communities, there are many, many communities, so it's not, you know, it's a modest but you know, useful advancement. But what I think we did is to strengthen the fabric between all of those players. I'm not sure if that answers your question.
And that's excellent. I think that's a true story for anyone. I have meteorologists in my family, and it's always that frustration of there's so much work and so much like useful information being produced, but somehow it's not getting to where it needs to go. So I think it's a really excellent example of how it can be done. Yeah.
Oh, thank you, Judy.
All right. So if we don't have any more questions in Zoom land or here in the room, I might just finish off by thanking everyone for being here. Of course, thank you, Professor Scott, for making your way from Toowoomba all the way up to here to participate in this presentation. And with that, I'll just close the seminar today, but just reminding everyone who's connected to stay in touch through the newsletter or through the ACPIR website for our next upcoming seminars. And thank you very much. Have a lovely rest of your day.